Good morning, class. We are looking at application of trigonometric functions 8.3 polar coordinates. We are looking at polar coordinates. So we looked at the law of sines, the law of cosines, and now polar coordinates. The objectives are plot points using polar coordinates, convert from polar coordinates to rectangular coordinates, convert from rectangular coordinates to polar coordinates, transform equations between polar and rectangular form. So various identities from fundamental identities are Pythagorean identities, quotient identities, reciprocal identities, sum and difference formulas, trigonometric functions are periodic functions. They are all odd with the exception of cosine. Law of sine and law of cosine are mentioned here. Double angle, half angle formulas are given here. Sine 2a is 2 sine a cosine a. Cosine 2a has three different formats. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. And they give rise to an appropriate formula here. From here you go to alphabet and you take a root here. So again, more and more formulas that you've been exposed to, okay, are given here. Right triangle a squared plus b squared equals c squared. A plus b is 90 degrees. The sine is the opposite over hypotenuse and cosine is adjacent over the hypotenuse. You can figure out the rest. If this is a horizontal line, angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. For an object below the horizontal is called the angle of depression. To find direction of bearing, either you deal with north and only a clockwise angle and nothing else, or you deal with north or south, whatever is the closest, and the closer angle, it has to be acute angle. So for example, this one, we would say north 30 degrees, and then it's east. This one, the closest is south, south 20 degrees east. So those are the bearings. Here's the new one, 8.3, polar coordinates. In a two-dimensional coordinate system, each point on a plane is determined by, we can go with the rectangular coordinate system x comma y, also known as a Cartesian coordinate system, a distance from the y and x axis. X is a distance from y, y is a distance from x. Or we can go with number two, polar and represented with r comma theta, a distance from a reference point called the pole, and an angle from a reference direction called the polar axis. So if we put the two axes together, so this is the grid that we are familiar with, known as a rectangular coordinate system. Now, in the case of a polar, we have the origin here, or the pole, we're going to call it. And the x-axis on the positive side is called the polar axis. So here's the summary of the section. polar is represented, any point, any coordinate is represented with r comma theta. And that can be represented infinitely many different ways. How? If you add multiples of 2 pi, 2k pi or 2n pi, that's the same point. In other words, go more revolution around the pole. A complete revolution is 2 pi, so 2k pi. You may represent r as a negative and then add the pi to this one. When you add pi to this one, then you can also add 2k pi. K is an integer. K is an element of an integer. This is an element of, and I stands for the integer. So this is an element of, and I is following set. All right. Maybe I make it larger here so everybody can see I. The set of the following numbers. So the x-axis or the polar axis, a point with coordinates x and y can be represented with distance from the pole r and theta. And so polar has coordinates r theta, rectangular has coordinates x, y, where x is r cosine theta, y is r sine theta. Rectangular is x comma y, polar is r theta. So if you want to go from rectangular format to polar, you use the fact x squared plus y squared is r squared, x squared plus y squared equals r squared, Pythagorean theorem. Tan of theta is the opposite over the adjacent y over x, and always adjust for the quadrant as far as the value of theta is concerned. Plot points using polar coordinates. For example, we want to plot the point with the polar coordinates 2 comma pi over 4. And so here's the pole. Here's the polar axis. You can think of it as a positive side of the x-axis. The very first thing we do, we come up with theta. So from the polar axis, draw an angle of pi over 4. Go up, or in this case, 2 tick marks, or. And in this case, theta. So we make an angle of pi over 4, and then we go 2 tick marks, and that would be the answer. For this one. How about negative 3 2 pi over 3? Well, first, we make up the angle 2 pi over 3. First, we start with the angle. Now, it is important, going back to that, positive 2 is on this side. If for any reason this was negative 2, you would have the same angle. When you go to the opposite side, that means you are negating the value of r. So This is theta. This is the positive side. This has the same size. That's why we put it an absolute value. So this is a polar with coordinates r comma theta where r is negative. So what do we make up? This is the polar axis. We make the 2 pi over 3. And if it were positive, we would put 1, 2, 3 here and we would be done. But it's negative in the opposite direction. We go with three tick marks. So the opposite direction, and that makes a negative 3, 2 pi over 3. So it's pretty straightforward. All right, we want to plot the points again, starting as always with theta. Start with the angle. Here's your pole, here's your polar axis in all cases. So you go 5 pi over 3. You draw a line and you go how many tick marks? 3. 1, 2, 3. Two comma negative pi over 4. So we start with theta. Pi over 4 is in this direction, positive direction. Negative pi over 4 is in the negative direction or the clockwise. Negative pi over 4. We draw a line and we go how many? 2 tick marks. 1 and 2. 3, 0. Please understand 0 is the angle. So that means along the positive side of the x-axis or polar axis. And all we have to do, we need 1, 2, 3 tick marks. So 0 refers to the x-axis on the positive side. For the sake of argument, pi or 180 degrees refers to the x-axis on the negative side. We want negative 2 and pi over 4. First, we make up the pi over 4 angle. Okay. If it were positive, we would have a positive side and 2 tick marks. Because it's negative, the value of r is negative, pi over 4, and you continue. On this side, we make 2 tick marks. We check the second tick mark. So this would be positive pi over 4. And that's fine. Because we want r to be negative, we have to go this way. And then 1 and 2 tick marks because of what we have here. So that's how we do the drawing. We want to plot the point with coordinates 3 comma pi over 6, and here's our polar axis. So we make up the angle first, pi over 6. Then we draw a line and we go with 3 tick marks. 1, 2, 3. So this is 3 pi over 6. Now, we want to plot P such that R is positive, theta is between 2 pi and 4 pi. So we really want the same point, right? And since we want it to be 2 pi and 4 pi, that means really add a complete revolution. So all you have to do, add a 2 pi, everybody. Add a 2 pi, right? Because it says 2 pi to 4 pi. 2 pi to 4 pi. So if you add a 2 pi here to pi over 6, which means 13 pi over 6 in essence. So you are going to add a 2 pi, and the result is the same spot, but now the sum of the two is 13 pi over 6. We have changed the value of theta by adding 2k pi, more specifically k is 1 here. We are not changing the location of the point. Here's another one. We want to go with the same point. This time we want R to be negative and theta between 0 and 2 pi. In other words, don't change that, okay, if you don't have to, but change this to negative. So how would that work? You can't not change that. If you want R to go to a negative value, then you have to add a pi to this. Now, you can add pi plus 2k pi. This means odd multiples of pi. This means even multiples of pi. So I can add pi or 3 pi or 5 pi or 7 pi. Because I want it to be between 0 and 2 pi, I'm going to just add a pi. That's all. So I'm just going to add a pi to this. So when I add the pi to this, I must change number 3 to a negative value. Now, pi over 6 and pi is 7 pi over 6. Notice what happens. So you go 7 pi over 6, end up here, right? Because it's negative, you go the opposite direction, okay? And that gives you the same spot as the original point with coordinates negative 3, 7 pi over 6. Pay attention to what we have here. Now we want R to be positive, so this is not changing. However, we want theta to be negative between negative 2 pi and 0. And that's very simple. All you have to do, remember, to pi over 6, you can add even multiples of 2 pi. That's the meaning of 2k pi, even multiples. So I can add 2 pi, I can add 4 pi, or I can subtract 2 pi. So in this case, because I want to go from negative 2 pi to 0, because I want to make this negative, I'm going to add a negative 2 pi. In other words, subtract 2 pi. So when I subtract 2 pi from pi over 6, I end up with negative 11 pi over 6. So I'm going to keep the R unchanged, and I'm going to subtract 2 pi from theta. Okay. So in essence, I'm using this, okay, because this is an even multiple of pi. Adding or subtracting makes no difference. Remember, k is an integer. And so minus 11 pi over 6, you draw the line and you tick mark 3. That gives you the same spot, okay? So minus 11 pi over 6, and this is the pair, 3 comma minus 11 pi over 6. The point being, a rectangular coordinate system has a unique representation of a point, but a point in the form of a polar coordinate has infinitely many different ways to be represented. All right, so we have this rectangular coordinate system such that this point has coordinates x comma y, and we have this polar axis such that this point has coordinates r comma theta. So how do we go from r comma theta to rectangular form x comma y? X is r cosine theta, y is r sine theta. It's that simple. So this point has coordinates r theta or x comma y, and here's the relationship among those. We want to convert from polar coordinates to rectangular coordinates, and again, x is r cosine theta and y is r sine theta. Well, if we were to plot the pair, okay, we would draw power 6 here, and then we would go 6 tick marks, and that gives us this answer. Now, x is r cosine theta. As you know, cosine of power 6 is a common r. Cosine of power 6 square root of 3 over 2. That's the answer, 3 square root of 3. So the x is 3 square root of 3. The y is r sine theta. As you know, sine of a power 6, a common arc, is 1/2, and 6 times that is 3. Therefore, this point with polar coordinate 6 comma power 6 can be represented by x comma y, 3 square root of 3 comma 3. All right. What about part B? Let's graph it. The way we graph it is very simple. Minus power 4. So this is minus power 4. Now this is negative 4. If it were positive 4, we would go 4 units here. But because it's negative 4, we have to go in the opposite direction. So this is the point we are looking for, everybody. So take a look at what we are looking for. First, understanding the pair again. So this is negative power 4. This is the positive direction. We want the negative direction. Okay. For example, this point would be positive 4 comma minus power 4, but this is what we want. Now, what is x? R cosine theta. R cosine theta. R is negative 4. Cosine of minus power 4. As you know, cosine of minus power 4 is the same as cosine of power 4 because cosine is an even function. So this is the same as cosine of power 4, which is square root of 2 over 2. So minus 2 square root of 2. That's as far as x is concerned. As far as the y is concerned, y is r sine theta. Now, this is negative sine of power 4. Why is that? Because sine is an odd. Remember, all trigonometric functions are odd functions, except cosine, which is even, and therefore so is secant. Now, negative times negative, everybody. Negative times negative makes it positive. So positive 4 sine power 4. Sine of power 4 is the same as cosine of power 4 squared of 2 over 2. This 2 cancels out 2, and it becomes 2 square root of 2. Therefore, this pair, which has coordinates minus 4 minus power 4, is the same as rectangular coordinate having coordinates minus 2 square root of 2, positive 2 square root of 2. That's the same. Using x equals r cosine theta and y equals r sine theta. Convert from rectangular coordinates to polar coordinates. The pair has coordinates 0, 3, and we are reminding everyone that rectangular is in the form of x, y, polar in the form of r, theta. X squared plus y squared is r squared, tan theta is y over x, and we want to adjust for the quadrant. R, theta is the same as r, theta plus any even multiple of, pi, 2k pi can be added. Or if we want to make r negative, then we must add a pi, or better yet, any odd multiples of pi. When we say theta plus 2k pi, that's the meaning of it, everybody. All right. Plot the point. 0, 3. We are using the grid. Determine r and theta. Clearly, this is power 2. So any point along the y-axis on the positive side has an angle of power 2. On the negative side, 3 power 2. Okay, everybody? Power 2 up here. 3 power 2 down here. 0 power 2, this is pi. Okay? And 0 angle is the same as 2 pi or 4 pi or even. And what is r? Distance from the pole. 3. So r is 3, theta is power 2. We want to write a pair such that with 3 different criteria. Part A, we want r to be positive and theta be between 0 and 2 pi. So basically r comma theta, just the way it is, 3 and comma power 2. And we're done with part A. Everybody, this is part A. This has 3 parts. We are going to move to part B in a moment. But for now, this is the representation of this rectangular point in polar format. Now we want R to remain positive, so 3 is not going to change. However, we want theta to be negative, and we want it to be between 0 and minus 2 pi. Remember what happened here. You can add multiples of 2 pi or even multiples of pi. So I can add 2 pi or I can add negative 2 pi. It's the same thing conceptually. So I'm going to subtract 2 pi in essence. When I subtract 2 pi from this, it gives me part B. So pi over 2 and negative 2 pi, negative 3 pi over 2. So that's part B. That's the answer to part B. That's the answer to part A. Let's go with part C. We want R to be negative. So clearly we want to change this to negative 3. However, we want this to be between 0 and 2 pi. And remember, you can add odd multiples of pi. So all we have to do is just add 1 pi. If we add 1 pi to this, it becomes 3 pi over 2. And 3 changes to negative. And this is the answer to part C. This is the answer to part C, everybody. Now, just for the sake of argument, if I want others, for example, if I add a 2 pi to this, everybody, 3 and 5 pi over 2 represents the same point, and I can continue indefinitely. There are many different ways, infinitely many different ways to represent this pair. That's what I'm trying to tell everybody. Okay, so this thing continues indefinitely. But we did answer the 3 parts they asked us. All right, we want to convert from rectangular coordinate to polar coordinates. We want to discuss some of the obvious ones. For example, if it's along the x-axis or the polar axis, if you will, okay. So if you go a amount to the right, then it has a comma 0 in both cases, whether it's x and y or r and theta, because y is 0 in a rectangular coordinate system, theta is 0 in a polar coordinate system. So along the positive side of x or the polar axis, a 0, they are identical. Now, y-axis. On the positive side of the y-axis, okay, x comma y, they have coordinates 0 comma a, right? If this is a. So a is the r and theta is pi over 2. So along the positive side of the y-axis, any point with a rectangular coordinate system has an x coordinate of 0. Even on the negative side, the x value is 0, but we want to go to the polar coordinates, so we want to stick with the positive side only. And if the distance is a, okay, the y coordinate is a, becomes your r, okay, and of course pi over 2. If we go on the negative side of the x-axis, okay, this a0 changes to minus a0, okay. When we have minus a0 and we want to represent it with positive a, then the angle is pi. What's interesting, you could represent this as minus a and 2 pi or minus a0. If you put as minus a0, that also represents the same point in polar coordinates. Okay, remember, if you want to represent a with a negative, then you add a pi here. So pi and pi is 2 pi over 0. If we are looking at the negative side of the y-axis, okay, this angle is 3 pi over 2. Any point has coordinates 0, minus a. So the distance r is a, but the angle is 3 pi over 2. And again, we are using a positive a for all of them. We are using positive r for all of them. Okay. Of course, that's not unique. You can represent it differently. But if we were trying to stick to positive value, this is how it works. Or r. Convert from rectangular coordinate to polar coordinates in general, where the pair is 2, negative 2. So we are going to plot the point and determine r and theta. So on the rectangular coordinate system, you just go 2 units to the right and 2 units down. That's really the bottom line. So 2 to the right, 2 down. So it's very straightforward. And now, as you know, r squared is x squared plus y squared. So r is the square root of x squared plus y squared. 2 squared and negative 2 quantity squared. This is 4. This is 4, makes it 8. So it's square root of 8. And square root of 8, as you know, is 2 square root of 2, because 8 is 4 times 2. 4 comes out as 2. What is theta? Theta is y over x. If theta is y over x, if tan theta is 1 over x, theta is tan inverse of y over x. So I want to make sure we, okay, so if this is the case, class, that indicates that theta must be tan inverse. And you have to figure out the quadrant. So when we look at the tan inverse of y over x, we get tan inverse of negative 1. And as you know, it's negative pi over 4 from the fact that inverse tangent, we have limited the domain of the tangent from negative pi over 2 to pi over 2 in order for it to work. So negative pi over 4. So we found r to be 2 square root of 2, theta to be negative pi over 4, and this is a correct answer. However, we can write them differently if we are asked, for example, to write this pair such that r is positive. Okay, so that's not going to change. But theta, we want it to be between 0 and 2 pi. All you have to do, make this positive. How? Add 2 pi. If it's not enough, add 4 pi, 6 pi, 8 pi until it becomes positive. So I add 2 pi. If I add 2 pi to negative pi over 4, I get 7 pi over 4. The second case wants to make r negative. So let's make this one negative. And then we have to add a pi. So we need to add a pi. When you add a pi, you get 3 pi over 4. So you make the r negative, you add a pi, and negative pi over 4 changes to 3 pi over 4. So they all represent the same point. Again, unique when it comes to rectangular coordinate system, not so much so when it comes to polar coordinates. But again, you got it just for the quadrant. This one, the quadrant was the fourth quadrant, and theta was minus pi over 4 or 7 pi over 4, by the way. So rectangular has coordinates x comma y, polar has coordinates r comma theta, x squared plus y squared is r squared, tan theta is y over x can't be zero, it's just for quadrant. This has been explained already. So if it's the first quadrant, tan inverse of y over x is the answer. It just worked out. If it's in the fourth quadrant, the same thing. Well, the R is the same for all of it. Just understand the first and we just did the fourth one. However, if it's in the second quadrant, okay, then you have to add a pi. If it's in the third quadrant, you have to add a pi as well. The third quadrant is very clear because it's positive, and it gives you the first quadrant. You have to add pi. This one, very clear because it's negative. Negative gives you this, and then you add a pi. Okay, that's as far as how you adjust it. So quadrant 1 or 4 theta is the same as tan inverse of y over x. But the other two, you must add a pi to adjust for it. So it's very straightforward, everybody. All right, transform equations between polar and rectangular forms. R is 4 sine theta. We want to change this to a rectangular form, and we want to identify the graph. Reminding everybody that r squared is x squared plus y squared. Y is r sine theta. Remember, rectangular x comma y, polar r comma theta. Okay. Tan theta is y over x. We want to adjust for the quadrant. Polar is r comma theta to go to rectangular x comma y. X is r cosine theta. Y is r sine theta. So this is the synopsis of that, everybody. So when we have r equals 4 sine theta, the technique, and it comes with practice and experience, is to multiply both sides by r to figure out what we have. If we multiply both sides by r, take a look. This is x squared plus y squared, and this is 4y. So we changed it to a rectangular. Now we are going to work on it. To work on it, we're going to move the 4y to the left. You may recognize the equation as a circle, or you may not, but I'm going to remind you in a moment as far as how this thing works. If we put these two together, we need to add 4. If we put these two together, let me just, when you put these two together, remember to make it a perfect square trinomial. This is your b divided by 2 and square it. We add 4 to both sides. This is completing the square. Completing the square. So the left side is x squared plus y minus 2 quantity squared. The right side is 4. So I'm going to remind you about circles. X squared plus y squared equals r squared, centered at 0, 0. x minus h quantity squared plus y minus k quantity squared equals r squared centered at h comma k. Okay, those are, I hope everybody remembers the equation of a circle. Okay, centered at 0, 0, centered in general at hk. Therefore, this is a circle centered at 0, 2 with the radius of square root of 4. Square root of 4 is 2. So I'm looking at this, okay? Equation of a circle. I hope everybody's okay with those. Very straightforward, everybody, okay? Transform equations between polar and rectangular. 3x squared plus 3y squared is 2x. We want to take it to polar. And again, this is the information from the previous page. We also remember x squared plus y squared equals r squared. So on the left side, we can factor the 3 out. Now x squared plus y squared is r squared. So this is replaced by r squared. X is replaced by r cosine theta. So the left side will be 3r squared and the right side will be 2r cosine theta. We can drop r from both sides or divide by r. And normally we solve for r. And we get r is 2/3 cosine theta. R is 6 cosine theta. We want to take it to a rectangular format and we want to identify the graph. The technique we used previously was to multiply both sides by r when we have r and sine or cosine. On the one side we have r, on the other side we have sine and cosine. In this case we have cosine. It doesn't matter 6 cosine theta or just cosine theta or 10 of it. Multiply both sides by r. The left side becomes r squared and the right side 6r cosine theta. So the left side is x squared plus y squared, and the right side 6x. We move the 6x to the left and we put it next to x squared. And we are going to do completing the square. This is b, remember that. So b divided by 2 is -3. Squared is +9. We are going to add 9 to both sides. So the left side is x minus 3. What happens to the left side? It's always x plus b over 2 squared. Whatever the sign of b over 2, because b over 2 is negative, so negative 3. This will always be the when you do completing the square, okay? So x plus b over 2, that means x minus 3 quantity squared plus y squared equals 9. And now this is a circle centered at 3, 0, and the radius is square root of 9 or 3. This is r squared, remember that. This is r squared, everybody. Okay. So again, just reminding you of the equation of a circle. For xy equals 9, we're going to take it to polar, which means 4 times x or cosine theta times y or sine theta equals 9. So replace the x with r cosine theta and y with r sine theta. So we have 4 r squared sine theta cosine theta. And you may change that sine theta cosine theta. If I write this class as 2 here, 2 here, this is sine of 2 theta. So I have 2r squared, 2r squared times sine 2 theta equals 9. Let's transform equations. Between the two. So this is clearly a rectangular form. Let's take it to a polar form. That's what they mean. X squared plus y squared is r squared. X or cosine theta divide by r. So I can get rid of this and this becomes r. So r is cosine theta. Y equals negative 3. There's really not much you have to do. Y, replace it with r sine theta and you're done. R equals sine theta plus 1. The technique is to again multiply both sides by r. When we do that, this becomes r times r. This becomes r sine theta. This becomes r. And class, obviously by r times r, we mean r squared. So this, everybody knows it's r squared. And so therefore, we can use that. Let me actually erase that because we need that one to show you what each one happens. So I'm going to replace this one with x squared plus y squared. R sine theta, I'm going to replace it with y. What about r? If this is r squared, I can replace the r with the square root of that. So one more time, r squared clearly is this one. R sine theta clearly is y. What is r? Well, if this is r squared, r would be the square root of that. What about r equals 4? The technique is to square both sides, which means r squared is 16 in essence. So what is r squared? X squared plus y squared equals 16. And I hope everybody can easily recognize this as a square. My apologies, a circle centered at 0, 0 with the radius 4. And you recognize x squared plus y squared equals 16. It's even easier to represent it in polar format, r equals 4. R equals sine theta plus cosine theta. Again, you may recognize the technique that basically multiply both sides by r. So here's what we get. This is r squared again, class. And we know this is obviously x squared plus y squared. What is r sine theta? Y. What is r cosine theta? X. And by the way, this can be, everything can be moved to the left. Do completing the square and figure out what you have, which is a circle, and you figure out the center as well as the radius. Convert from rectangular coordinates to polar coordinates, and we have -1 comma -3. So we're going to plot this pair which belongs to the third quadrant. This is plotting it. Okay. So x and y with coordinates -1, negative square root of 3, and this is the theta. So what we need as far as r comma theta is concerned is to calculate the r and the theta. R squared is x squared plus y squared. We can calculate the r, and then tan theta is y over x, and we adjust it accordingly. So let's go with r being square root of x squared plus y squared, which means this one squared plus this one squared. As you can see, this is 1. This is 3, makes it 4, and square root of that is 2. So we found r, we need to find theta. So tan of theta is y over x, which makes it minus square root of 3 over -1, which makes it positive square root of 3. And as you note, this is a common arc, theta is pi over 3. However, pi over 3 is here. This is in the third quadrant, everybody. We must add a pi. We've discussed that before. So that's why just going through the process is not good enough. If you plot the point, it will help you come up with the correct angle. So we add a pi to pi over 3, and that gives us 4 pi over 3. So the pair -1 comma negative square root of 3 is the same as 2 comma 4 pi over 3.